Hello everybody, how are you? I'm Smith Tucker, hoping you're fine. Today we are going to learn something about the constants, variables and data types in C language. And I'll give you the bit about the knowledge of preprocessor, which is much necessary things for defining the universal constants in C language. Basically, what is a data type? You all might have a basic understanding, but today we'll have a bit of theory knowledge and we will have a good practical. Now, what is a data types? A set of values and a set of those values. Why data types is used? Data type is used to identify the variable when the variable is declared. Identify the return value of a function and identify the type of parameter expected by a function. Data type has many uses, but basically we use the data type to store the value, identify the parameter expected by the function, and identify the variable when it is declared. The syntax for a data type is something like this: int the data type, then identifier. For example, I write a, then equals to, then the value. Basically, it is declared like this. Most mainly, the data types are initialized by the initializing operator equals to. That we will learn later, but let's continue. When a compiler encounters a declaration for a variable, it sets up a memory location for it. When you declare a data type, the memory location for it is set up. When you apply a legal operator which is defined in the particular language, then and only then the data type is considered a valid and the value initialized in it is considered the valid rule. Now, when we talk about the identifiers, means the naming of a data types, there are certain rules for constructing the identifiers in C language. Capital letters A to Z, lowercase letter and uppercase letter, 9 0 to 9 and underscore character. First character must be letter or underscore. Usually only first 32 characters are significant. When you give long identifier to a data type, if it is greater than 32, then only first 32 characters are considered. Then get no empty blank spaces. You cannot keep the blank spaces in naming a variable. You can also not declare an data type as identifiers. The case are sensitive. Now, data types are classified into two types: built-in data types and a programmer-defined data type. It can also be called a user-defined data types. Now, what is built-in data type? Fundamental data type. The basic fundamental data types are int, character, double, float, void, and pointer. The concept of pointer we will learn later. And there are also a derived data type: array, string, and structure. Programmer defined data type: structure, union, and enumeration. Now, int is used to store only the integer values belonging to Z. Character data type is used to store the character values. Double and float are used to store floating points, but the capacities are different. And void is used to show that the function does not return a value. Pointer is used to specify the memory location, which we'll learn later. Now, in derived data types, array is used to store the multiple value in a single variable. String means like a name, but in C there is no data type called string, so we will be using character array. And structure is like a vector in Java, which is used to store the different type of data type. It is similar to array, but you can use it to store different data types, while in array you can store only the similar data type in a variable, while in structure you can store different type of data types. A programmer defined data type, structure, union, and enum. Enum is a quite useful thing when creating your own libraries and function. Structure and union are quite similar, but the memory allocation is very different. Now, font void. Void is used to denote the type which is no values. Int is used to denote integer data type. Character is used to denote a character type. Float and double is used to define the floating type, which we talk later. Int star, float star, character is the syntax for pointer. Now, the uses of fundamental data types. This is a program which we are going to do later. Now we will see a bit revision of derived data type. A finite sequence of variable of the same. This is the exact definition for derived data type, but ANSYS is taken as ANSYS book by E. Balagurusamy is taken as standard, in which definition is quite different, but basically all the definitions are same. The main thing is the uses in every place is same. String an array of character variables. Structure a collection of related variables of the same or different data types. That these three things we would be learning later. And the uses of derived data type are practical. We are not gonna do, as it is the last second chapter of our C language. Before we go with the practicals, we would be a bit there is little bit theory left. Now, what is cryptograph? We will discuss something about cryptograph characters. Cryptograph characters are the few characters which aren't supported in is used to define some characters which aren't supported in old characters. Nowadays, cryptograph characters aren't used, but in some keyboard, all the symbols and all the special characters like ampersand, comma aren't present. So we use cryptograph character. Now we will learn something about the C tokens, and then we will be starting some practicals. Now, what are C tokens? In the passage of text, individual words and punctuation marks are called C tokens. Basically, C tokens are the basic building blocks of C program. There are mainly 6 types of C token: keywords, constants, strings, operators, identifier, and special symbols. The use you will see as you do the practicals. Now, let's start with the practicals. First of all, as we know, we are going to include libraries as we usually do. Studio.h. I don't have a turbo compiler, so I'm using Microsoft Visual Studio. It has good advantages as it provides the IntelliSense. Basically, but Visual Studio is used to develop the apps for .NET framework, but I use it for C language also. Here, as we are declaring void main, means that the function does not return a value or returns the 0 value. Now, we will declare some data types and print them using printf statement. Int a. Let's initialize it. So 5. Wait for a second, we forgot to include that ch as the output wouldn't be stored. Now we got 5. Okay, but if you initialize a with 5.2, then there will be error generated or you won't get the output which you want. the 5, it's only 5 because integer variable does not support the floating points. To have floating points, you need to declare float b equals to 5.5. Now we will also declare percentage d comma b. Here we should not declare percentage d, we have to declare percentage f, as we are referencing the float value. See, we got the output. But if we do point to f, made a mistake. Point after percentage you write 0.2f or 0.3f, and only the number of floating points will be taken. This chapter would be the 4th chapter of the programming, but this is general use, so I told you guys. Now we take the declaring part from here, and now we will read from the console screen. We'll be using scanner function. Percentage d, percentage f, comma, %, comma, %. We'll paste it here. We will add 1, 2.4. Now, if you take 2.4 and 1.2, then only 2 and 4, 0.1.4, 1.2 will be the output, because here you have taken int. So understood? Now we will be using, I'll give you a bit knowledge about preprocessor, and we will make a function that converts temperature, and I'll say you goodbye. Define EI 3.14. Now if we wish to calculate the area, then we can take int, we'll take float a comma b. No, we'll take something logical, radius, radius comma area. As we will be adding the float values, we are taking the radius and area as a float type. Then we would be doing an in-depth statement. We'll print some message, enter radii plus radius of layers, then use of scanner function, percentage d, then statement. Before we go with the printf statement, we need to initialize area equals to radius into radius into pi. Here we use the pi, it will get automatically 3.14, as we use the preprocessor there. Percentage F. Comma. Then the similar on the program. Wait a second. 1, 2, let's see. Here we need to take percentage F. I want to show you the array, so I add a percent T. That's it. It works. Now we add point to F, so we get perfect output. Cut. Now we'll see the size of variables. We'll be using size of function for that. Int equals to 5. Float will be directly size of data. Comma. Size of and we will be doing same thing with float. Command C and command V. Float. Then same thing with a character data type. Comma. Size of character and same thing for size of long. Then we will also do it for short. Percentage T, size of short. You can also do it for double. Size of it's double, okay. Wait for a second. Exactly. Long double. We will also be doing for signed in and signed in. Signed in means it can store values. It can store all values, and unsigned in can store only the positive values. This unsigned int can only store the positive values. The size of function returns the value of the data type or a variable. Signed. Okay, now we will simply write get ch and let's see the output. Let's put the slash in. Something for pattern. Note. For yeah, character. Same thing for long. Same kind of stuff for short. Same stuff for double. And same stuff for unsigned and same kind of stuff for signed int. Save it. Let's check the output. We get the memory allocated by them. It is a size in bytes. Int 4, float 4, character 1, long 4, short 2, long double, unsigned int 4, and signed int 4. We got the output, all we wanted. Okay, thanks for watching my tutorial.